It started yesterday with cryptic messages from Nvidia, ARM, Windows and MediaTek, a new era of PC, and a couple of coordinates. It was very effective, creating a lot of hype. Today, during the Nvidia GTC keynote in Taipei, Jensen revealed the product behind the hype, the Nvidia RTX Spark. Let's take a look and talk about it. I'm sitting in my hotel room in Taipei right now, and it's not without some irony that about 2 years ago at Computex 2024, I first heard rumors about a collaboration between MediaTek and Nvidia for an SoC. It took longer than expected, but in October of last year, the chip was finally released. I'm talking about the Nvidia GB10 inside the RTX Spark. And GB10 or versions thereof are also what's powering the new RTX Spark. It's such a new chip. The chips shown at Computex are from week 42 of 2024. That's October 2024. This chip isn't new by any definition. I'd even call it old. Let's take a look. The specs for the RTX Spark are as follows. Up to 20 Grace CPU cores, a pretty large Blackwell-based iGPU with 6144 cores, and a wide 256-bit memory interface with up to 128GB of LPDDR5X. Sounds pretty good to me. But again, these specs are exactly the same as GB10, the chip inside the RTX Spark. That's because both RTX and RTX Spark use the same chip. And thanks to kernel insights, we already have die shots of GB10. GB10 is a chiplet-based SoC with a CPU die and a GPU die, a bit like Strix Halo. The CPU die was designed by MediaTek and the GPU die comes from Nvidia. From what I'm hearing, getting them to work together caused some problems, that's why the chip was delayed so much. On the GPU side, GB10 looks great. The Blackwell-based iGPU contains 6144 CUDA cores, the same amount as a desktop RTX 5070, and comes with a pretty large 24MB L2 cache, plus Nvidia's great D and encode hardware. GPU and CPU die are connected via a high-speed NVLink die-to-die interface, which is important because the memory interface is on the CPU die. With 256 bits, we are looking at a wide interface. Again, AMD's Strix Halo comes to mind. The CPU die also contains a large 16MB SSC type cache and plenty of I/O. So far so good. But where things aren't looking so good anymore is the CPU cores. What Nvidia calls a 20-core Grace CPU is in reality an implementation of 20 standard ARM cores, 10 X925 and 10 A725. Not bad cores, but pretty old. Both core types were announced in May of 2024, over 2 years ago, which fits very well with the first production dates of October 2024. The 20 CPU cores are split into 2 clusters, each containing the 5 large X925 and 5 smaller A725 cores. Interestingly, the 2 CPU clusters aren't exactly the same, with one cluster coming with an 8MB and the other one with a large 60MB shared L2 cache. Asymmetrical design, kind of interesting. So what does all of that tell us? First, the Nvidia RTX Spark isn't new by any definition. Early GB10 chips have a production date of October 2024 and the 20-core CPU is based on ARM's last-gen core design. The latest ARM architecture is the C1 series, and in just a few months we are expecting an announcement of the C2 generation, which means when RTX Spark launches in fall, it might be 2 generations behind in terms of CPU architecture. Does that mean the RTX Spark is a bad product because it uses older CPU cores? No, of course not. We know exactly how good or bad it is because the RTX Spark has been out since last year. Benchmarks show that the CPU performance of the RTX Spark is good but doesn't quite match Qualcomm's latest Snapdragon X2 Elite, especially when it comes to single-core performance. GB10 is a great chip when it comes to local LLM users because the large Blackwell iGPU combined with 128GB of VRAM over a wide 256-bit interface is great for everything AI. And of course, such a large GPU will also perform great in gaming. Well, if there wasn't the crux of Windows on ARM and the immense cost of the large VRAM size. Unlike RTX Spark, RTX Spark for laptops will also come with smaller VRAM sizes. But remember, we are talking about shared memory here, so your memory pool has to cover traditional system memory and VRAM, which means less than 32GB will be a problem even for gaming. To be honest, Windows on ARM has come a long way in the last 2 years. I'm editing this video on an Asus ZenBook A16 with Qualcomm's latest Snapdragon X2 Elite Extreme, and everything I do runs extremely well. DaVinci Resolve and Photoshop, just like most other apps, already come in a native version, and the X2 Elite just blows through all of my workloads. But it's not great for gaming, just because Windows on ARM isn't that great for gaming yet. In my opinion, Nvidia's RTX Spark is a Strix Halo for Windows on ARM. It will perform great for everything AI, but cost an arm and a leg. And for gaming, Strix Halo will still be the better choice, just because it runs the full x86 Windows experience. And for Windows on ARM, the latest Snapdragon X2 chips don't have to fear RTX Spark. I'd wager most users will prefer the higher CPU performance over the bigger iGPU if they aren't running LLMs. So not a new era for PC, just an old chip with a big iGPU for laptops. Let's hope Computex has more to offer.